Today we are going to talk about nested triangles. And here we are. Nested triangles are two triangles that share a common angle. If you look at this drawing, we have triangle ABC and triangle ADE that share the same angle A. Nested triangles are always similar to each other, and you can use measurements that you find in them to find what's missing. Now, how can this be useful to us? So let's say we have this situation. We have this river that there is no bridge. We need, for whatever reason, to find out how wide the river is. What do we need to figure it out? We need few stakes. We need the measuring tool. So we need to pick, let's say we stand here at point A, and what we need to pick a point, something across from the river. Let's say a tree that is right straight across from us, and then another tree on the other side of the bank, and let's say these two trees are B and C points. We need two stakes and a measuring tool, we said. So what we do, from the point where we stand, we walk straight towards that tree that is across. When we hit the bank, we put the stake there. Then we go back from the point where we stood originally, where we need to put the stake before we even do anything. We start working towards the other tree, and when we hit straight, it has to be in a straight line. When we hit the bank, we put the stake there. And now, here is what will happen. We will actually have a triangle created here with a triangle created there. Now what we need few measurements. And we need this measurement here, how long that is, how long this is. And then we can actually measure how long that is, because we start walking from this stake and we walk along the bank here until we get across from that one, measure that distance, and we actually can figure that one there. So here is what happens. So now on this drawing we have this. So we measure that this is 30 feet, let's say. This is 50 feet, and that's 100 feet there. If we separate these two triangles, the small one, which is ABE, we have a measurement of 30 feet here. We know that this is 50 feet. On the big triangle, label it ACD, we know that this is 100 feet. In order to find the width of the river, we need to find how long this side is. So this is what we are looking for. So to do that, we need to find the scale factor. So this should be is. What is the scale factor from the small triangle to the big? Why? Because we are looking for this long side on the big triangle. So we need to enlarge 50 feet to find that one. So the scale factor that would enlarge that would be the scale factor bigger than 1. These two sides correspond to each other, and we know them both. We can use them to find the scale factor. To find the scale factor bigger than 1, we put the larger corresponding side on the top and the shorter on the bottom. And now we actually use that scale factor to find the how long is this side here. So we take a corresponding side, 50 feet, and multiply by the scale factor. We multiply that, so we go 50 times 100 and then divide by 30. We end up with 166.6 repeating. I will round it to 2 decimal places, which is 166.67 feet. But that is actually this whole distance. That's not what I want. I want only the width of the river. So what I need to do, I need to take this 50 feet off of that measurement. So 166.67 minus 50 feet will give me 116.67 feet width of the river. So now let's look at the second example. And here what we have a two nested triangles. We have some measurements we need to find all that are missing. So let's label them first. So the first small triangle is ABC. And what I know in it, I know 4 centimeters here, and I know this length to be 3 centimeters. I don't know side AC. I will have to find it. On the big triangle, which is triangle ADE, I know the bottom side, which is 6 centimeters, and I know this long side, which is 10 centimeters. I need to find this side AD. So I will obviously need both scale factors because I need to find one side on the larger triangle and one side on the smaller triangle. So the scale factor from small to big would be, to go from small to big, I can use these two corresponding sides, I know them. From small to big, I need scale factor bigger than 1, which means put the larger corresponding side on the top, smaller on the bottom. That would give me a 2. And then from big to small, I need to go vice versa. Put the shorter one on the top, bigger one on the bottom, and we have 1/2 or 0.5 because it's a terminating decimal. Now when we have the scale factors, to find side AD, I need to use the corresponding side to it, which is 4, and multiply by the scale factor to enlarge it by 2, which will give me 8 centimeters. And then to find AC, I need to use corresponding side, which is 10, and multiply by the scale factor to shrink it, which is 1/2 or 0.5, which will give me 5 centimeters.